Hey everyone, welcome back to another video for one of these kind of grade 4 to grade 9 videos. So in this case we're going to be doing the inequalities topic. So inequalities are kind of something that's kind of overcomplicated in my opinion by a lot of people. They are actually very similar to regular equalities, which we call equations, right? So we might have like 4x plus 3 equals 4. If you can solve something like this, you can solve any inequality. Okay, because the only difference is that instead of an equal sign, there's an unequal sign. What does the prefix in mean? It means not equal to in this case, okay? So all we're going to be looking at is the various different ways of doing that. So, for example, start with the grade 4, so this is foundation and higher tier. So n is an integer such that minus 2 is less than equal to n and less than 3. So write down all the possible values. Well, it says less than, but this underline means equal to as well. So it can equal minus 2. Then it can be minus 1, 0, 1, 2. Now this sign means it's less than 3, but it's not equal to, which means we can't write the number 3. On a number line, we have to show the inequality x is greater than minus 3. So the way you show inequalities on a number line is you first draw a circle at whatever the number is on the right hand side. So in this case, minus 3. Okay. Now you decide if you colour in the circle or you leave it hollow. Here's the rule. If it's not equal to, so if there's no underline, you don't colour in. If there is an underline, you do colour in. Okay, that's it. Then you have to decide which side the arrow is going to go. So in this case, it's saying x is bigger than minus 3. So which direction is bigger than minus 3? Well, if I go left, it's less than, right? Because the numbers are getting smaller. So it's going to be to the right. And all you do is you draw an arrow, go all the way to the right, and you actually put an arrowhead on it as well to show that it goes on forever, because it does. And again, it's hollow because it's not equal to. So doing something similar. 1 is less than equal to y, which is less than 5. Write down all the values. Well, it equals 1, then it goes 2, 3, 4, and it doesn't equal 5, so I don't put in the number 5. Now, what about solving inequalities? Well, again, this is where a lot of students get a bit confused. You can treat it exactly the same as if you're solving this. The only caveat is that if you divide or times by a negative number, you have to flip the direction of the inequality. In this case, I can see I'm not going to be dividing by a negative number, so I don't have to worry. So what would I do? Well, I'd subtract 7 from both sides. That gives me 4t equals 12. Divide both sides by 4. That gives me t is equal to 3. So the last step then is you just put the old sign back. So the way that looks on the inequality side of things is you just minus 7 from both sides, exactly the same way. So if you look, the steps are all the same. The only difference is the actual sign. And then divide both sides by 4. And yet t is less than equal to 3. Okay? So again, you treat it exactly like you would if it was an equal sign, unless you divide or times by a negative number, in which case you need to change the direction. So in this case, it's facing to the right. We would make it face to the left. If I, let's say, times by minus 1. Write down the inequality shown on the number line. Okay? So the first thing I'm looking at is it's hollow, which means it's not equal to. And as I can see, it's on the number 2. So I'm going to write down x and the number 2. Okay? That's it. Where did I get that from? Well, it's always going to be x in this case, if there's nothing else given. And it's the number 2 because that's where the circle is, right? Now, is it less than 2 or is it greater than 2? Well, it's going to the left, which means it's less than 2. So I put a less than 2 and I don't put an equal sign. I don't put the underline because it's not equal to. Okay? On the number line, show the inequality minus 2 to 4. Okay? This is where it gets a bit more funky. We're going to put a circle on minus 2 and on 4. And then we're going to decide, are they hollow or are they solid? Well, in this case, they're not equal to, so I leave them hollow. And then all I do is I draw a straight line, or as straight as you can, line between them. That's it. Part B, okay, we actually have a coloured in one now. It's at minus 2, so I'm just going to write x and minus 2. And I know I'm going to have the underline, so I'm going to put the underline there now because it's a coloured in circle. And it's bigger than. So I'm going to put x is bigger than. So in order to determine which direction it is, by the way, just think that this kind of crocodile mouth always goes to the bigger thing, right? So in this case, x is bigger than -2, so it faces the x. If -2 is bigger than x, face the other side. Okay, so that's it for foundation. So if you're all happy with that, well done foundation guys. You can leave and rest up, maybe do a few practice questions. For those of you doing higher, we're going to move on to the grade 6 and then the grade 9 stuff. So grade 6 stuff is actually showing inequalities on graphs themselves, which is fairly funky. And you can either be asked to describe the inequalities shown by the shaded region or to draw the inequalities themselves. And here's how you tell. Well, the first thing I want to go through is if the lines are dotted, it means it's not equal to. Okay? So these lines are all solid. So solid means equal to. So you're going to have the underline. Dotted means not equal to. Okay? Which means you won't have the equal sign. Okay? So in these cases, all of them are solid. So what would I start with? Well, I like to look at this vertical one. That's quite easy to do. Okay? And what is the equation of this line? And that's all you need to think, by the way, is you need to think about what's the equation of the line. Okay? Well, it's a vertical line, so it's x equals something, right? And in this case, it's x equals -2. Now, if I look at the shaded region, is that to the left or to the right of x equals -2? Well, it's to the right, isn't it? And to the right is when x values get bigger. So you're going to write x is bigger than -2. And again, it's not, and it's equal to in this case, because it's a solid line. Okay? Cool. So we've done one. That's already 1 mark done. What's the next easiest line? Well, I like the look of this diagonal line that goes through the origin, because that is just going to be y equals x. Nice and easy. And once again, I ask myself, is it greater than x or is it less than x? So is y greater than x or less than? Well, if you look, the shaded region is above the line, which means it's bigger than. So you're going to have y is greater than equal to x. And lastly, we have this line here. This one's a bit more of a pain to deal with because we actually need to work out the equation of the line. So what we're going to do is do y equals mx plus c. I can read off what c is. It crosses at 1, so c is just 1. And m, well, I'm going to use a small triangle this size. So that goes up by 2, goes from 2 to 4, and it goes across by 4. So 2 divided by 4 is equal to 1/2. So that is y is equal to 1/2 x plus 1. And again, I ask myself, is the shaded region above that line or is it below? Well, it's below that line, so our final one is less than equal to 1/2 x plus 1. And again, because it's not dotted, I actually put the equal sign, okay? If it's a dotted line, you would not have this underline here. Cool. Let's do another one. Write down the 3 inequalities again. So again, I'll try and go roughly in order of difficulty, if you can. So this bottom line here, that is just a horizontal line, which means it's going to be y equals something, right? Well, what is it? Well, it crosses at -3, so it's just y equals -3. And again, I ask myself, is it bigger than or is it lower than? Well, it's above that line, so it's definitely going to be y is bigger than -3. And the last thing I ask myself is it a solid or a dotted line? That is a solid line, so I need to put the equal sign. Okay. Now for these other 2 lines, let's do this one first. Let's do a little tiny triangle. So it goes 1 across and it goes 3 up. So that's going to be 3 over 1. So the gradient of that is 3. And it crosses at 3. So it's 3x plus 3. And if you look, the shaded region is below this line. So we're going to put y is less than 3x plus 3. And again, it's a solid line, so I need to add the underline. It's easy. For this one, yeah, it looks like it might be a bit painful. Actually, it's not too bad. Dotted line here, dotted line there. It goes 1 across and it goes 2 down. So it's going to be 2 over 1, but, which is 2, of course. Since it's going down, though, we need to make it negative. Okay? So again, m for this is 2 over 1, which is 2. But because the line's going downwards, it becomes negative. Where does it cross? It crosses at 0. So that's just y is equal to minus 2x. And as you can see, it's underneath the line. So again, we're going to have y less than equal to minus 2x for your 3 points. This is a 4 or 5 mark question. Pretty good, right? In fact, this is 5 because you have 2 equations of lines that you have to work out. So 4 or 5 marks, pretty dang good in my opinion. Now we have to do kind of the opposite. We have to shade the region that satisfies all of the inequalities, x less than 3, greater than minus 2, and this. So again, all you're going to do is do it one by one. So how do you do this? Well, what I do is I find out where x is equal to 3 would be, which would be a straight line going up, so a vertical line going straight up. Now if you notice, it's not equal to, which means we have to use a dotted line when we do this. And what I would do to make the examiner's life a bit easier is literally write out the equations of the lines that you're drawing. Okay? Just so they can quickly just look at it and tick off what you've done. Y is greater than minus 2, very similar. We're going to look at y equals minus 2, which is going to be a horizontal line here. And as you can see, it's not equal to, so we're going to do another dotted line. And we don't care about the greater than bit or less than bit just yet. That comes later. Now this one's where it gets a bit trickier. Depending on how good you are at plotting graphs, I'd recommend A, just labeling the y-intercept, so that's minus 1 right here. Then the 2x means for every 1 you go to the right, it goes up by 2. And then once you have kind of 2 coordinates, you can kind of find the rest. And this is a solid line because it's less than equal to. So let's do this. Let's make it... Again, you would be using a ruler in your exam, so please forgive the terrible presentation. Put your ruler straight through and draw it. Okay, this gives us the majority of the marks, but now we have to actually shade in a region, label it R. Well, let's start with our x equals 3. It's less than 3, so that means it should be to the left of this line, right? Cool. You can probably already see what the equation is, like what the shape is, but bear in mind that they sometimes try and trick you. So a lot of people just shade the triangle, label it R, and you're right about 80% of the time. 20% of the time it might be somewhere out here or up here. They've done it before to trick people. So make sure you do some level of working out. It's bigger than minus 2, so we look at that. So it should be above our y equals minus 2 line, and it's less than equal to 2x minus 1, so it should be below this line. So indeed, it's this middle area, label it R, done and dusted. Another one, except it's slightly trickier, because the first thing we need to do here is actually rearrange this. So minus x on both sides, you get minus x plus 4. So let's label it. So we've got a 4 here, right? And then the minus 1 means for every 1 we go across, we're going 1 down. So it's just like a nice, easy line. And because it's not equal to, this is going to be a dotted line going down like so. Mine's not perfect. Again, you need to use a ruler. Y is, so actually let's label that line. Y is equal to x plus 4 minus x. I'm going to change that to y is greater than 2x plus 1, so we're just going to plot 2x plus 1. So plus 1, that would be here. And then the 2x means for every 1 you go to the right, you're going 2 up. So if you look, they actually overlap ever so slightly. So let's draw a straight line going through these. Yeah, that's good enough. And that's y is equal to 2x plus 1. And lastly, but certainly not least, we have y is greater than... Oh, that shouldn't be a solid line, actually. Dang it. That's what I get for rushing. And lastly, we have y is greater than minus 1. And again, this isn't a dotted line. Minus 1's over here, so let's just draw a horizontal line here. Now, if we have a look, we have 2x plus 1. It should be greater than 2x plus 1. Ah, interesting, right? So greater than 2x plus 1, so it's actually above this line. It should be lower than this line, so down here. And it should be greater than minus 1. So if you have a look, if I move this over slightly, this might make a bit more sense. It needs to be below here and above this side. It's actually the outside part of the shape. Okay, so this is one of those cases where they definitely have done or can do this part. Okay. Some people prefer to shade in all three regions and then pick another color for the actual region that they want. That's also okay. So for example, you'd shade everything that's above this line one color, shade everything below this line another color, shade the last one that color, and then label the region. But that's a bit complicated in my opinion. And then lastly, but certainly not least, grade 9 heavy hitting quadratic inequalities, which may come up this year. I have a funny feeling they might. And a lot of people are probably sitting there thinking, that's easy. But people make mistakes every single time, and I'm going to show you. So to solve quadratic inequalities, it's the exact same, almost, as solving quadratic equations. So you can use quadratic formula, you can use factorization. Let's use factorization. So two numbers that times to 3 add to 4. That's going to be x plus 3, x plus 1 is greater than 0. And then you're probably tempted to say, well, x is minus 3, x is minus 1. So that means it must be minus 1 less than equal to x less than equal to minus 3. Right? You'd be tempted to say that. And you'd be wrong. Okay? Now, 90% of the time it is like that. But not 100%. And we care about 100%, right? We want to get those grade 9s. So, why did we go wrong? Well, if you look, we're looking for the values above 0. This is where it gets complicated. The easiest thing you can do is lightning fast sketch the quadratic. Now, I would like to point out these questions are 4 or 5 marks. So they give you more than enough time to do this. And then if I sketch this out, we have minus 3's here, minus 1's here. So we're going to have a quadratic that looks something like this, right? Where that's minus 3 and that's minus 1. The accuracy doesn't matter that much. Now, if I look, I'm looking for the values where it's greater than 0, which means it's above the x-axis, right? Because that's when it's greater than 0. Below 0, this equation's negative because it's giving me a negative value for y. But it is greater than 0 over here and over here, okay? Which is not defined by this, is it? Because this region here is between minus 3 and minus 1. In that region, it's actually less than 0. So if this inequality sign was less than 0, this would be 100% right, because between minus 3 and minus 1, it does go below 0. But we're looking for when it's greater than 0, which if you look, happens when x is less than minus 3. And is it equal to minus 3? Well, let's think. At minus 3, x equals 0. Do I want x equals 0? No. I want bigger than 0 only. So it's that. And when x is greater than minus 1. And once again, since we don't care about actually equaling 0, it's just greater than, not greater than equal to. Okay? And that would be the final answer and the correct answer, which generally gives you 2 marks, by the way. Okay? Because you get a method mark for actually getting this, and then also the answer mark for getting the correct final equation. So again, if it's less than 0, this is 100% fine. If it's greater than 0, you have to do this kind of split inequality. Eventually you'll be able to do it in your head, but just so you're aware, like imagining the quadratic, right? I don't know if you guys are that sad that you imagine quadratics now, but unfortunately I am. But I hope that makes a bit more sense, okay? It's not that complicated once you think about it, right? So let's do another one as an example. X squared minus x minus 20 is less than 0. So let's think about it. We want two numbers that times to minus 20 and add to minus 1. I'm thinking minus 5 and positive 4, right? One has to be negative, one has to be positive. So then we get x minus 5, x plus 4 is less than 0. So if we look at where it equals 0, we get x equal to 5 and x equals minus 4. So then we draw out our little graph and we have minus 4, let's say that's here, let's say 5 is here. And then draw our little quadratic. Again, it doesn't have to be too accurate. And let's look at what we're looking for. We want when it's less than 0, so that's when it's below the x-axis, right? Which is this region over here. And how do I describe that region? Well, it's greater than minus 4, right? And less than 5. Now, if you look, I can actually define this properly as one big inequality, right? By doing that, which is actually how you should be leaving your answer. If x is between two values, which it is in this case, you always draw an inequality like this. Don't do it like this, okay? Because again, it's between those two values, so you should just draw it, write the inequality like this, where x is in the middle. So it's saying x minus 4, 5. It's in the middle between them. And is it equal to? Well, again, this inequality is not equal to, which means this inequality should not be equal to. Okay? So it's kind of covering like a little mistake that I see a lot of students make. This actually comes back in A-level maths as well, and A-level students make this mistake too. So try not to be one of them. Anyways, the download link for these questions are all in the description, so you can have a look, try them again in maybe a few days' time, or whatever you want to do. But other than that, I hope your revision goes well, and I'll see you in the next one.